Alright guys, welcome back. If this is the first episode you're seeing, we're creating an entire third-person controller from scratch. And today, we're creating the first component of the state machine. Over the next few episodes, we're going to be writing a lot of code to build up a good foundation for our state machine to work off. So gear up and let's get started. Before we begin, don't forget to like and subscribe. If you want the entire course right now, you can support me on my Patreon or become a channel member for instant access. Or skip the monthly fee and grab the full course on Udemy. Lifetime access included. Links in the description. Now let's get into today's lesson. Okay, so we're back, and now that we know why we need to create a state machine, let's start working on creating a state machine. So the first thing I'm going to do is create a new folder in the player, and I'm going to call that state machine. And within this, I'm actually going to create a new script. So what you can do if you don't want to create a script on an object in your scene, you can right click on the folder and you can create new script. And the first one is going to be the state. It inherits node. That's fine. We're going to use nodes for this particular state machine, and I'll hit create. And within this, we have this state now. And so what you'll find is you've got a script with a ready end process and it extends node, right? But you can also create new script, and here you can also set the template to be object empty, which for us is actually more suitable. So we can create that, and basically it just says extends node, which is exactly what we need because we don't want to use ready or process. Okay, so we actually need to create two new classes for this particular state machine. We need the state machine, the thing that runs the actual states, and then we need the state. Now, I thought it would be easier to create the state first, just to give you guys a sort of an idea of how these are going to look, and then we'll create the machine, which is the code that will run the states when they're active. All right. So something you can do in Godot is make your own class. So when you see extends node here, this is a class, and it extends means it inherits. So this new script, which I forgot to rename, so we'll just rename that and we'll call it state. This new script here, it extends node, right? And we can create something that inherits all of node, but also has its own name. So we can go class name, and then we can call state. Now these typically have a capital letter, as you can see for node. So we can say class name state. And so now we can create objects called states. So if we wanted to say create an object here and we type in state, hang on a minute, let's just save that. And we wanted to create an object and we wanted to create state, you'll find it in this create new node. So we can create a state and it will have the script attached to it. That's pretty handy, right? So the state is the thing that's going to actually do the processing. So it's going to be idle, run, whatever. And it really just needs 4 functions, right? And they're pretty similar to what we normally use for a regular node, right? So we're going to create a function called enter. It's actually not going to do anything, and it'll return void. And it's going to essentially stand in for the ready function, right? So instead of being called when the node is created, which is what the ready function is, this will be called when the node is activated. So when the state becomes current, enter will be called. And then likewise, we'll need a function called exit, and it returns void. And we'll just set return here. And it's the exact same thing. When we exit a state, we're going to call this function, right? And finally, we need the input. So we need to get the input. Now, I like to call this state input so that I can tell the difference, right? It takes an event just like a regular input function would, and it's an input event. And same as before, it returns void. And we can just type return on that. And last but not least, we need the process function. Now, I'm just going to call this update. It's sort of similar to what you see in other game engines. Godot calls it process, but instead of being called every frame, if it's not active, it won't be called, and we'll call the update function of the current state in the process function of the state machine. It takes delta, which is a float, void, it returns void, and we can just type return there. Okay. And last but not least, we actually need to create a signal. So when we want to exit the current state, we're going to fire off a signal, and it's going to be fired to the state machine. and the signal will carry the next state as a string. We can hit save. Now, you will actually find that you get a couple of warnings here. The signal finished is declared but never explicitly used, and the same with event. So what you can do with event, you can just put an underscore and that warning will go away. And then with the signal, it's saying the signal finished is declared but never used in the class. Well, we're going to use this in the subclasses of this class, but that's actually not going to help us. So what we can do is actually just go warning ignore, and we can pass in unused signal and hit save. And that'll go away. So now we don't have any warnings, which is great. So that's what the structure of a state is going to look like. Now we need a state machine, something that can run this particular state when it is the current state. And we're going to actually do the exact same thing. So we're going to create a new script. It'll be node object empty, and this one will be the state machine. Okay. And it's the exact same thing. We're going to call class name, and it will be called state machine. Okay, so now we have a state machine. So there's a couple of things the state machine needs to have in order for it to work properly. The first is I'm going to make an export variable, a starting state. So we can go start state, not state, start state, and that'll actually be a state. So it's defined now, so we can find it here. And we need a map, a dictionary of all the states that can possibly be accessed. So we have a state map, which is going to be a dictionary. And then we also need to know what the current state is. And this will also be a state, and it's actually going to be equal to null to start with. And then finally, we are going to have a active variable. And so if the state machine is not active, it won't run. And we can turn it off in certain instances, like for example, a cutscene would play or the character died. You can go to the state, the final state, and then stop the state machine so input stops running, something like that, perhaps. Okay, so those are all the variables that we might want. And so what do we need to do? The first thing that I'm going to do is create some pretty simple functions like we've had before in the camera. We're going to have an input function, and this time, instead of actually doing anything, we're going to go current state dot underscore state input and then just pass on the event. So you can see that the state machine is really just going to be passing on that function to the current state, and so that it can only run one at a time. And same with process. I'm actually going to use physics process here. Current state dot update and then pass on delta. Okay, and so generally speaking, our input and our process are only going to run on the current state. But how do we get to the current state? Well, we need to set the current state. We might have a function called initialize, and that will take a state, returns void, and we could just set the current state to be equal to the state, and then we can call current state.enter, right? Which is the same as our ready function, right? So we can do that. Now, I mentioned here the active, so we can activate it or not activate it. So perhaps we need to create a function. We can even do a set get if we want to. We can just put a colon there and we can go set and then another colon and then set active. And then of course we will need to create that function. So we can come down here and go set active, and that will take a value, which is a bool, and it returns a void. Just type pass for now, see if we can get the checker to be happy. Expected that after set. My bad, this needs to be an equal sign. Now we've got to set active. What do we actually do with that once we actually set it active? Now we want to set active to be true, and we might put underscores in front of all this because this class is going to be inherited. So we want to make active equal to the value, right? And then we also want to set the physics process. So we don't actually want to run the physics process if it's inactive, right? So we type set physics process as value, and we'll need to update this as well because it's not happy. Okay. Set physics process, and the same with the input. So we can type set process input, and we can make that equal to the value passed in here. Okay, and then lastly, if it's not active, then we want to set the current state to null and just reset essentially. Okay, so now that we've got a set active in the initialize, we want to set active to true since it's false by default. And that means that until initialize is called, we won't actually be running any states. So we need to create a ready function. So I'll do that up the top because that's where they're meant to go. So we can go function ready, and we want to call initialize. So initialize, and it wants the start state, right? If it's happening in the ready function. Okay. And then finally, we want to be able to change states, right? So we've got our states running in the input and physics. We've got initialize, so we're starting the states and we're setting it active when we start. But how do we actually change states? So we've got a function here. It's going to be called underscore change state. And it's actually going to take a state name, right? And string, and it's going to return void. And if the state machine is not active, so if not active, then we don't need to do anything. We're just going to return, right? It's a mistake. Shouldn't have been called. Let's make it a little bit more space here. Okay, so the first thing that we want to call, if we're changing states, on the current state, we want to call that exit function that we created before, right? So back in state, we created an exit function. This is going to get called. It's the last thing that's going to be called on that state before we go into the next state, right? But how do we actually know what state to run? Now we've got the string name of the next state, but the states are nodes, right? So how can we get them? Now I've created that state map here. We haven't defined it yet or created it, but that's what we're going to use. So the current state is going to be set to the state map, and we're going to use that string to look up the node in this dictionary. Okay, and then we want the current state dot underscore enter, right? And that's going to be called. So we'll be in the new state at that point, and then the physics process and the input process will continue. Okay, but how do we create this state map? Now, we haven't actually done anything in the player yet, but now we're sort of at the point where we can, right? So we can create a new node, and this is a little bit easier if we do it like this rather than adding a state machine. And so we want to add a script to this, and we're actually going to call this the player state machine. And it's actually going to inherit from the state machine. Okay. And we'll create this, and this will be saved in the state machine. I'm going to create a new folder called the player state machine, and we'll save that there, and we'll create that, right? And we don't need any of that. I'll just delete it. Okay. So we've got a blank script here. We've got a start state. We don't have any states. So I'm going to call this the state machine. Okay. And we'll create a new node. Now we can create our state, say our start state, which would be idle. And then we could duplicate this just for ease. We could also have a run, right? And by the way, Control D duplicates the nodes. That's how we do them so quickly. It's just a little bit faster than adding one. And then we also want to have potentially jump and also fall and so on and so forth. If you want to add other states, feel free to do so. Okay, so now we've got the states, but they're not actually states at the moment. So if I click this, they won't show up. So we need to add scripts to these. And this will be idle. Potentially, it will inherit a state as well. So we can go state, the path, inherit state, built-in script, idle. I'll go to state machine, player state machine, and then I'm also going to create another folder here called states, and it will be called idle, and we'll create that. Okay. So now we have the idle state, and then we can do the same for run. And we can save that in the states here, run. we're going to change this to object empty because we're going to need to create through this. So just go through and create scripts for each of these. Jump. By the way, if you ever forget, you can always just type in extends and change it. It's no problem. Object empty, state machine, player state machine states, jump, create, and then same for fall as well. Attach script, inherit state. Actually, you know what? Let's just do one that's wrong so that you guys can see what it looks like. State machine, player state machine states, open, create, and it says node, but it's pretty easy to change because we haven't done anything yet. So we can just change it to state. Since it inherits from node, that's not going to cause any errors. Okay, so now we've got 4 states and we can set the starting state. And obviously the start state will be idle. Now, obviously these don't do anything yet, but we'll work on that. So now let's go back to our parent script state machine and figure out how we actually populate this state map. So one thing we're going to do is create a function. I might do it under initialize. Actually, I might do it before initialize since that's when we're going to do it. So I'm going to create one called create state map, and it's going to return void. Now I'm going to make an assumption here, and the assumption is going to be this is the general layout, and we don't have sub states, right? Because that is a possibility. You could have that, but this, we're going to keep it simple for now. And we're just going to have a state machine and the children are going to be states. So for the state map, we can actually just loop through the children. So we can go for child and we can actually type this. So we can go child state in get children, right? And children just returns the children nodes of the parent node, right? So we're just going to get all 4 of these in an array and we're going to loop through them. And we can just go state map child dot name, which is the name of the node, right? So that as a node, this is where inheritance comes into key here. Node has a property which is called name, right? And this is the name of the node. The name must be unique among siblings. If other child nodes from the same parent, when set to an existing sibling's name, the node is automatically renamed. So basically, it's a unique name that we can use to refer to a node. So this is really powerful right now. We're going to leverage that. And in the state machine, child state name equals child. So now we're going to create a dictionary with the state, with the name of these as the key. So when we change state, we need to pass in the name of that node. So you know now it's going to be a string name of idle, run, jump, fall. Okay. Okay, but how do we actually connect all this up? So let's have a look at the state for a second. We've actually got a finished, right? And this goes to next state. So this is the change state trigger. When we call finish, or when we emit the signal finished to the state machine, we're actually wanting to change states, right? So we could go to the state machine here and know that we need to connect the change state function to the finish signal. Okay, so here in our create states map, while we're looping through these children, we can also go child.finished.connect, and then we can connect change state. So, and just remove that. So finished the signal, connect, obviously we're connecting that signal to the function callable, that's what that takes, change state. So now when each of these children emit the signal finished, it's going to be called back to this parent node to the change state function. And last but not least, don't forget to put the create state map function into the ready function here. All right, because without that, we won't have a map, which means our change state won't be able to read from it, which means we won't have a name to look up in our state map. So it is a very important function, needs to be called in the ready. Right. That is setting it up. I know it's a lot to take in, and it's a lot of overhead for something that doesn't actually do anything right now, right? So in the next lesson, we're going to create a parent class to control all of these individual movement states. That's going to give us all the different functions that you would expect to find in a movement that you're going to be needing to call in all of these. All right, see you there. All right, guys, that is all for this episode. I hope you found it helpful. Next week, we're going to be taking our final step in creating a component that all of our movement states can inherit from. If you're finding this series helpful, please remember to like and subscribe. If you want to get access to every single episode in this series, you can become a channel member or join the Patreon. Other than that, guys, I will see you all next week.